Hi, everybody. I'm very happy to be here. Thanks for coming. I hope you will enjoy my talk. Um, so I want to talk today about data products. From zero to hero, so it's, of course, a nice name, but it's up to you to judge, right? Um, so as you see, I work for Lidl, and for those who live in Europe, I probably should not introduce and tell much about Lidl, because it's probably at every corner. But for those who live outside of Europe, Lidl is a discounter, retail, basically. We are present in 28 countries and in Serbia and in the US. So it's a huge operation. We have more than 10,000 stores all over the whole Europe and more than 300,000 employees. So as you can imagine, this is an enormous company that sells food, and most of you know about it, I guess. Analytics at Lidl has been there for quite a long time, but the machine learning data science has started just, about 3 years ago. The use cases we are working on mostly have to do with predictions of sales, how to stock shelves at the stores. But also we work with marketing departments, we work with, on use cases that have to do with various promotions. So it's actually a very exciting time to be at Lidl now, because we are growing very fast and we are trying to kind of build the whole data science around it. So my talk will actually be slightly different than the others, I guess, because most of the guys who speak here come from startups, right? And working for a startup or even for a large startup is a totally different experience than working for a large enterprise. So for those who've done this in the past, I guess you know what I mean, but let me show you, first of all, right? So there is some info about myself. I'm a senior data scientist and machine learning engineer, so I guess that speaks for itself. And the reason why I'm here today is because our team, we have a lot of teams, developed the first data product, machine learning data product at Lidl, and I would like to share my experiences today with you, right? So I mentioned data products quite a lot of times so far, and we as a data science team, or the advanced analytics team, so to say, we try to make sure that every use case that we're working on results into a data product or a piece of software that everyone can use, right? So we're not quite interested in ad hoc use cases that, okay, you do it today and then tomorrow they come again and come again. So we're trying to build really the software, the automation for the whole company. Oopsie, I pressed something wrong, I guess. I need some help here. Oh, thanks. Yeah. So I will talk today about why we build data products, some tales about data scientists, so something you probably know already, and our analytics platform and the data product. So back in the dark ages, right? This is how people worked, but if you work for a large company, you probably still can find such, dark remnants of ancestry somewhere. What do I mean by that is that, well, people still use a lot of paper, they process things by hand. So what does it mean? That means there are a lot of opportunities for digitalization, more or less, right? And the challenge here is that a lot of companies that try to hire data scientists, but many struggle in the end to put the results of the data science work into production, right? So most of the time, data scientists work days and nights, and then they produce some models that they cannot explain to anybody, and then this stuff kind of dies. And then after 2 years, everybody leaves, and then they hire again, and then this is a vicious cycle that repeats. So I would like to share with you how we kind of try to avoid this havoc and move from, 0 to here, right? So by 0, I mean 3 years ago, we started completely from nothing. There was nothing, right? And after, well, some time, we were able to build data products. The first one came out recently, and then we're working on more stuff. So let's say, imagine a corporate situation, right? So some managers basically come together and say, okay, we need data scientists. And remember, those managers are retailers. They're not in any sense technical people, right? They say, let's hire 2 data scientists. We heard that they are unicorns. They can do magic, right? That's what they do, right? They just say they hire 2 data scientists, right? And by the way, you probably wonder why there is no Hadoop in the picture, right? There's Teradata. Well, Teradata is a large, relational store that can run in parallel. But this is actually one feature of large enterprises like in retail, Lidl, Tesco, or you name it, right? These guys actually had big data even before Hadoop came in, right? So think about they had to operate and collect all that data when Hadoop was in beta. So where would they put the data? How did they manage that? So of course they came to these vendors like Teradata, Vertica, or Netezza, and then these guys basically sold them the software. So there are a lot of legacy systems, but well, in our case, Teradata, of course, not a legacy system. It's a functional system that we use all the time. It's the center basically of everything. So. But I mean, imagine so they hire 2 data scientists, give them laptops, and say, okay, just figure something out. And then what happens is that one guy develops an algorithm, then gives it to another guy, and then it never works. So I know it's kind of something that everybody knows, but when you start from 0, the first step is, okay, you need to start and figure out how to run reproducible research, right? And the usage of Git is the first step in any way, right? So data scientists and the elephant, right? So after some time, management thinks, well, let's buy Hadoop. But before that, right? Before that, they still think the data scientists are unicorns, right? But the unicorn actually has four feet, not 2. Right? So you need at least 2 data scientists to become a unicorn, or you need something else, right? So say this is what happened to us, right? At some point, we said, okay, we need a Hadoop system because we want to build data products, and we bought Hortonworks platform for that. So we're extensively using Hadoop, Spark, SparkLyre as an R library as an interface for Hadoop, Hive, Apache Phoenix. I will mention these things later again. But in the end, data scientists, they like analytics, Python, R, but they don't know much about big data usually. It's a big problem, and stuff crashes all the time. So they just don't know. So the solution, right, how to get actually 4 legs, well, you have to hire data engineers, of course. Right? So only then somehow they help each other and the team starts functioning properly, right? So again, over some months, we had a lot of challenges with the Hortonworks platform because you cannot just use it out of the box. There's still some things that are misconfigured that just don't work. And another one is, well, there is obviously a lack of talent on the market, especially in Europe. I don't know in the US, but data engineers, we are hunting for them, more or less, right? So communication. So communication matters. I mean, it has been mentioned quite a lot of times in the talks today and yesterday. So and this is what happens usually, right? You have business person, and then you have a data scientist, and then, okay, this is what comes out. That's a funny story, but I mean, if there are business people in the audience, I mean, you probably have experienced something like that in the past. So how do we solve that, right? Of course, you need a product owner on the team, right? What does it mean? You need a translator, right? When you have relatively large data science teams, when you have junior members, ability to talk to the business is super important, right? And again, think about it. It's not a startup situation where everybody knows each other and everyone is open to communication, to solving problems, and everyone seems to be on the same page, right? At the large enterprise, it's totally not the case, right? You walk in to talk to somebody and you say you're a data scientist. Guess what they do first? At first, they start Googling what is data scientist. And then maybe they will talk to you, right? So obviously you figured out already we are using Scrum. We're quite agile at Lidl. And each project needs a Scrum Master in order to translate requirements and explain to data scientists what the business is really thinking. So why, again, so data scientists are not superhuman. So this story about data scientists communicating with businesses, it works, but in small companies usually, because there you are mostly on the same page. Teamwork matters, right? So data science is a team sport, right? You need teams of, business people, you need engineers, you need UI developers, you need data scientists, right? So it's a team sport. So, of course, there is a lot of miscommunication, just like everywhere. But most importantly, right, think about a large enterprise, right? There's a big budget, right? And then the budget goes to sub-departments, and they're free to spend the money the way they want. They don't have to pay you. They don't have to buy your services, right? And if you cannot communicate with them or convince them what they want, or like understand what they want, then they just buy it somewhere from some other third-party vendor, right? So this is a big challenge for data science teams in general, and again, not in startups, because startups usually are short on cash, they cannot just buy whatever, right? But business units are free to spend their money the way they want, right? And if you send out a junior data scientist to talk to some, business person, if they don't find something in common 1, 2, 3 times, that's it, game over, right? So it's quite important. So coding skills of data scientists, right? So that's how they do it, usually. Don't take it as an insult, but I've seen it so many times. It's one large script. And sometimes it works, sometimes it doesn't work. Sorry, but it's like that. I haven't seen anything. I bet there are data scientists working at Amazon or some large companies that are able to code in C++, clean, but again, let's take the average company, right? This is what happens. So what we do at Lidl is we kind of try to come up with best practices and say the first product that we developed was done in R, and we teach data scientists to develop R packages to make reproducible code, not just code whatever scripts they want, but really to make it clean the R way, or say in Python, the Python way. So again, how we do it, of course, is a version of control. It's quite easy, everyone does it. But say for R, how do we do it? So you have to take some lessons from the Java world, right? How do you do it in Java? You build fat, big jar, right? You put everything there. What does it mean? That means you isolate your piece of code from, well, another data scientist piece of code, right? These are isolated units. Same thing you can do in R, right? You can create this large environment with all the dependencies, with all the packages, and this is how we deploy our products, right? As a big kind of a archive of dependencies. So clean coding in R is possible. I know that there are a lot of opponents of using R in production, but we actually do it. So it is possible to use R in production. Focus on value creation, right? Don't come up with some crazy models. It's most of the time you're solving a business problem, not a problem, I don't know, not an open source kind of a ticket, right? You have to be, help business instead of yourself, right? So is R unstable? Well, I haven't seen that so far. It worked pretty well. And of course, stay pragmatic, right? Pragmatism is what differentiates a junior data scientist from a senior data scientist in the end. So I wanted to show you this video. Probably most of you saw it in the past, but how do you fix a bug in production, right? So and there's another bug now, right? So, and I've seen this so many times. One company I worked in the past for had a Git repository linked to the production system such that data scientists could commit and push directly into production. And that's exactly it. So don't do it. So build isolated units just like in Java. You can do it in R, you can do it in Python. So it's come up with development. So the data is the new, so everybody knows that. So the message here is that invest time in data cleaning. This is super, super important. Even if it takes you, I don't know, 6 months to arrive at the code that cleans your data the best. So convince your stakeholders, convince your PO that this is the most important part because, you know, garbage in, garbage out, as easy as that. Ownership matters. So I like this one very much. Cascade of attention deficit teenagers. Who knows what that means? This actually comes from quite far at the... So this term was coined in the software development community and basically means that every time a project is inherited by the new team, they tend to rewrite everything in a new language, right? And that's an anti-pattern. Data scientists tend to follow this so much. I've seen so many cases where, okay, they develop a POC in one language, then they rewrite it in another language, and then they write it again in a third language. So just try to be pragmatic, right? You're solving a business problem, and that's the most important part. So this slide is more about, so, you know, all big companies, take it, oil industry, take retail, take whatever, they have this huge scale. And for instance, every time Lidl wants to build a new store, they don't learn how to do it, right? They have their own way, it's well documented. They come and do it in a few days, whatever, month, right? Same thing with in oil industry, right? So when they want to, I don't know, pump oil, they build this mining platform and they already know how to do it. They don't reinvent it every time. In data science and in big enterprises, you should strive to do the same thing, right? In order to enforce scalability, right? You need to build an analytics platform. So what do I mean by that? So say you have a number of data science teams and then they all work on their own project that eventually will become a product. Why forcing every single team to reinvent the same thing, how to deploy it, how to run it, how to do the software development in the end, right? So the clean way is to set up guidelines, more or less, set up the environments for data scientists to be productive, right? And that's what we do at Lidl, right? So we try to work on data governance and architecture, product development tools for teams, model governance, security, automation, and scaling, right? So these are the key components, and yeah, these are the actual key components of that, right? So we work on Hadoop architecture. We have a special team that develops just these particular tools. Configuration, scheduling, services modeling, so you name it, right? So let's just walk quickly over these things. So as I said, we're using Hortonworks platform. And we had a very great, very nice architect who built the architecture on top of the whole thing. The key here are logical environments, right? So what does it mean is basically you try to kind of separate your Hadoop HDFS file system into logical kind of pieces, right? You can name it development, test, integration, QA, production, but again, these are isolated environments such that if you do something wrong in development, it doesn't affect test or the other way, right? So the way we do it is we develop code in development, then we test table deployments, for instance, right, for Hive or for whatever else in the test environment. In integration, we test how our code works with the outside components, right? Because don't forget, a lot of legacy systems in enterprises, in large enterprises, it's a key to be able to integrate to the outside world. If you're not able to integrate your stuff into the outside world, you will lose. So overall, we build a consistent data store, lifecycle management, and it's a flexible and extensible system in the end. So this is just another slide that demonstrates that how it's done. But the key here is, again, you don't want to do it per project. You need to enforce structure such that everyone follows that. Again, configuration. So there has to be a kind of a way to configure every application, and it has to be standardized. Otherwise, this team uses whatever they want, another team will use something else, and then gluing it later together is a big pain. So in terms of the development and deployment tools, again, we have a developer and user guide for data scientists. So what does it mean? You can read the guide and understand, okay, this is my code, this is how I will package it, these are the naming conventions, these are the places where I write my data, these are the ways they should be named. And then other systems will automatically pick this all up, right? If you follow the guidelines, you don't have to struggle with the integration to the outside world because it's all standardized and it has to follow the rules, right? So we use extensively Spark, Hive. Apache Phoenix is a great tool, right? It's a layer, it's an SQL layer on top of HBase. Helps us quite a lot. We have application templates, right? So how do you build R packages? How do you build Python packages, Java, and stuff like that, right? Modeling, right? It's quite an important part. So for modeling, you need to know which model you build at what time. So it's a model management, model monitoring. So what does it mean? You have to log everything you can, whatever outputs, I don't know, ROC, AUC, errors, anything. As much as the more you log, the better. You're in control after that, right? We build model monitoring dashboards because you cannot, if you have, I don't know, 5, 10 products, you cannot just go and type the code all the time and see what's going on. One click and you see the full representation. This is how my model performs. Should I ring a bell or should I just go to sleep? And then, of course, use the models that you understand, right? Don't go into deep learning if you don't know what it is. Just don't do it. We have teams who try to use Keras for linear regression. Don't do it. It doesn't bode well, right? Don't do it. So another part is model output, right? How do you integrate your output to the outside world, right? So there are two ways. You can either pre-compute your results or you can build on-demand services. So with pre-computation, it actually works for use cases where you do some sort of forecasting, right? So where a user doesn't give you any external output, you simply kind of pre-compute and then you send it back to whatever system needs that. This can work, but not all the time, of course, because you cannot pre-compute all possible combinations. And in order to tackle this, we use microservices frameworks, right? So we use Spring microservices stack. So in order to do the service discovering and everything, we use Flask because data scientists are usually good with Python and they can code services pretty well. One thing that we're using is called OpenShift. I'm not sure how many people in the audience have ever worked with OpenShift or heard about OpenShift. So OpenShift is basically a framework on top of Kubernetes, and it comes from Red Hat. That was recently bought by IBM. It is the greatest tool I've ever seen. Really the greatest. I am totally for cloud. I love AWS, I like it, but OpenShift, it gives you so much flexibility and kind of isolates you from all of these details. So for example, if you want to work with AWS and, okay, you need to know how to build Docker container, you need to know what is Kubernetes, you need to know how to deploy all these things. It's quite a lot of knowledge, right? And data scientists usually do not have this knowledge. With OpenShift, 5 clicks and you can deploy your Flask, 2 clicks and you can scale it up. It is that easy. It is the best tool I've ever seen, honestly. So if you have a chance, try it. Simply try it. So very simple stuff. Model scoring, right? So as I said, you cannot pre-compute everything, so we built our model scoring infrastructure. So it's based on PMML, right? So PMML is a universal, interface for transferring model from language to language, right? So you can build a model in R or Python and then score it in Java and stuff like that. So we use open scoring. It's an open source software that we tweaked actually to store models in Apache Phoenix, simply because, well, for speed, right? You cannot store it in Hive or anything like that. You need something fast, right? So again, OpenShift. As you can see, actually you can deploy databases in OpenShift as well. Depends on what you want, but again, greatest tool I've ever seen. So the full picture, how the whole thing works, right? So we have, we get the data from Teradata. Usually it goes into Hadoop, our analytics platform, where it's all properly structured. We use Spark Lyre as a Spark interface, right? Really, really great library. I like it very much. Very clean. You can write very clean code, dplyr-like. We have a service platform on top of that is able to read data from Hadoop platform. And that's how we serve the results to the clients, right? In case it's not pre-computable. Another interesting topic is how do you actually debug models, right? So yesterday there was a talk and from a person from AEG, and there was a question about how do you debug your models, and the answer was, okay, we built ROC curves, see there is some. Okay. Well, this is not really debugging of the model. This is, proper data science workflow for model selection, more or less. When you debug a model, you can try to use explainable AI. So what is explainable AI? It's quite a new trend in the whole industry. It's basically a set of tools that allow you to query the model and see how it makes its decisions, right? So there are 2 different ways of doing it. So you can either build a model that is already explainable, such as, for instance, a decision tree or rule sets or rule lists, and there are quite a number of such models. Or in case you have a black box, like XGBoost or NMForest or something like that, you can use methodologies like Lime, SHAP, partial dependency plots, and these are great tools, right? They are great in the sense that you can quickly find model leakages. You can show these things to your stakeholders because these are natural explainers. What they do in a sense is, say you have a black box model and then you give it some example to score, and the method can produce for you, for instance, a series of if-else statements where it says, okay, this is how and how a decision is made. Of course, it's not a fully automatic thing. You have to, like, any debugging involves humans, right? But this is a great tool, not only, again, for debugging, but also for communicating your results to the stakeholders, right? Because you can show them, okay, this is how my model makes a prediction. It's because the price is greater than, it's because the price is, I don't know, because it's a product that is, I don't know, nothing comes to my mind, but it's, I can answer probably later. So, and then the first product that we built, it's called PV tool, and it's a PV, it's in German, means like a change of the price. So what we were mainly interested in is when we put our products on sale at our stores, how do they actually react? How do the sales react to the price and to, for instance, some marketing effects? And it's a large project. These are just two kind of slides that I could put together. But the main interest is its price elasticity, cannibalization effects, various reporting, and these things are all done by machine learning, right? And again, there's the explanation. So how, how our action planners work. So they make predictions for 4 months in advance, and we have to make such predictions. So all in all, I'm not going to tell you more. It's an internal project anyways, and we have a lot of other projects in general. And I want to thank you everybody for listening, for being here. And I want to just say a few words. At Lidl, we're always looking for great people. So if anyone is interested, we're hiring. Please talk to me or contact us. All right. Thank you.
Yes. Thank you so much, Andrey. Some bits were super funny, even for me. So thank you for that. Okay, so the first question is, you said you separated your systems into logical environments. Does this apply to your data too?
Yes. Well, that was the short answer, right? It doesn't say how. But of course, you have to, if you have, I don't know, environment for development, you need to bring data for data scientists to work, right? In some sense, there's some data duplication across environments, but you have to do it, otherwise, I mean, the whole concept kind of falls apart, right? We work with 28 countries, so you don't have to bring data for all 28 countries. You can just bring data for, I don't know, 3 or 4, just to keep it running, but in the end, yes.
Thank you so much. Thank you so much for making it a little longer answer than the first one. How do you implement localized ML results for every country in Europe? Does it work like that?
Well, it's not. So the whole system is configurable in a sense that you can bring any number of countries. So more or less, you have a pipeline that runs the whole calculation and machine learning. And then if I add, I don't know, another country to the configuration file, then the pipeline will also run for that country. So, but the point here is that so the project lives in, for instance, in the QA environment, and there may be other projects who live in the same environment. But underneath my project, there are also some kind of rules of how I move the data and where and stuff like that. So.
Thank you. For the next question, I would like to draw your attention to the name of the person who asked that, just saying. I love that. You mentioned you use R in production. What do you use it for exactly? What kinds of products per services?
So we use R for building pipelines. So we use R and Python, right? Some data scientists prefer to work with R, some prefer to work with Python. But mainly, R is all the data crunching, right? So of course, we don't have any services in like REST APIs that run in R. No, it's not the case. But everything that has to do with data crunching, machine learning, reporting, this whole thing is done in R or Python.
Thank you. What are some of your main KPIs and how did you manage to drive those in the past 3 years?
KPIs, not sure. data science KPIs or business KPIs. So how do we measure success? I'm not sure what you mean by the KPIs here, but
anonymous. Do you want to remain anonymous, or would you like to explain what you asked? Remain anonymous. Then you get to choose.
Okay, let me guess. I think it's about the model, like the team performance KPIs. Well, that's a hard question. I mean, we try to kind of motivate people, try to offer them development opportunities such that they stay motivated. But yeah, I don't know. So I'm not really in the management team, so I'm not measuring any KPIs on my people.
Okay, then feel free to skip it. Then we are heading to the next question. And what do you consider the main skills needed from your data scientists?
Well, from a data scientist, you should know really well machine learning. We've had a number of people interviewed recently, and somehow even that lacks sometimes, right? People don't simply read books before coming to an interview, right? So if you want to be a junior data scientist, then you have to demonstrate at least some knowledge of big data, just some reading. I mean, you don't have to know much how it all works, right? Because that comes from experience, but you need to know machine learning, at least read 1-2 books, and learn something about big data. You need to know at least the words and how the concepts behind how it works, right? And then, of course, we don't expect any software development experience from data scientists, simply because this is then really hard to find on the market.
Thank you. Then I might not end up as a data scientist at Lidl, but others might. Can you give some practical examples about where do you use machine learning in stores or online?
Well, for the moment, so we don't use machine learning in stores, of course. What we use machine learning for is for stacking of the shelves, right? So you need to be able to predict how much to order, right? This kind of thing. So in the stores, there are no cameras. There's nothing that can kind of detect that you're buying stuff. It's mostly forecasts. How much do we have to buy of whatever item in order that it's completely sold tomorrow, right?
Thank you. That is good to know. We shop at Lidl a lot of times. What does Lidl optimize for? Maximizing revenue or minimizing food waste?
It's actually both. So we have a project that has to do with, for instance, how much we should bake. So you know at Lidl there is a corner where you have all these bakery products, right? And the main challenge there is you should be able to increase the revenue, but at the same time decrease the number of pieces of bread that you throw out at the end of the day. So for that question, it should be the same. So the business will not accept something that optimizes just for one thing, right? If they get less revenue, then they are not happy, even if they throw out less stuff. So it has to be both. And in that particular case, we optimize for both things. In other cases, it depends, so it depends.
Thank you so much. Our time is up, but thank you so much, Andrey, for keeping us inside. And I really, really loved bits of your presentation, especially those bits that involve Chaplin. Thank you so for that. And thank you for being here and really just, it was enjoyable.
And thank you for coming, of course.